Video. DraftScience, and I think we're going to critique one of these physics girl videos again. Very poor. Just, but it just brings up a lot of subjects. It's this whole PBS digital studio. So I mean, PBS used to do stuff that was supposed to be, better than the silly networks, and now they've just become another silly network. And, the very idea of promoting a show called Physics Girl, which really isn't about a physics girl anymore. She's just a presenter of the show. Okay, written by other people, edited by different people, created by different people. Well, she did create it, okay. But she didn't do anything. Except read her script and be a girl. Okay, super. Anyway. This crap science. This is silly science for religious kooks, pretty much.
Over 100 years ago, physicists were trying to figure out how things glow.
Oh, gee. I think they were trying to figure that out 500 years ago and probably 1,000 years ago, so you probably don't even have any of that right either. They were trying to always figure that out because it was kind of, wow, that's weird kind of a thing. So I'm sure they all wanted to know, for thousands of years, why hot things glow.
Like molten glass or hot lava. It seems like a simple question and was being pondered by such physicists as Lord Rayleigh at the turn of the 20th century.
I give you a wooden skewer that...
Right, so this is some sort of adult thing? Yeah, I don't know. I mean, if I was Lord Rayleigh... and I wasn't entirely dead, and just a little bit dead, and I could actually see this, I probably wouldn't appreciate it, asshole. Yeah. Somebody should make fun of you when you're dead.
when touched to a flame, glows orange-red.
Rayleigh knew that the color of this glow depends on temperature. Like the sun that has a surface temperature of 5,500 degrees Celsius radiates a bunch of different colors that together look white to us. Or
okay, we'll buy that. Lots of different kinds of, let's say, movement, okay, is created when you make things really hot. And so it's, you could almost say, yes, you would expect the maximum type of accelerations would be possible and the fastest kind of movements would be possible. And so you would get the full range of visible light. But you also get a whole bunch of the other stuff, the ultraviolet and the infrared and such. So that has something to do with his purple hair, no doubt, and the whole cartoon atmosphere of this physics.
for me, at 37 degrees Celsius, I have this invisible halo.
Okay, so this is somehow important, the invisible halo of... So you did it rather quickly, that's why you need to sort of pause through it.
Of infrared light.
So you have a halo of infrared light. But yeah, we do see the blue here. So the blue is the cold stuff and the red is the hot stuff. Or is the yellow the hot stuff? But anyway, is it really a halo? Is that a scientific term? Halo? Oh, wait a minute now. It's not exactly.
Fun fact, infrared light is invisible to humans, but snakes can actually sense it from up to a meter away.
Oh, a meter, a whole meter. See, I love when people talk about that. They can sense it, which is really not really... See, they always say see infrared light, and they really can't see shit. Okay, they see a blob, and they say, oh, there's a blob. Something not dead is in front of me, because they see some sort of blob, an indication. But yeah, they're not really seeing. They're just, it's like a kind of sonar, except it's shitty. 1 meter, not very good.
Detect prey.
So this is a little bit, I mean, it's just a little bit, maybe it's adult humor. Oh.
Rayleigh wanted to understand where the light came from and come up with a rule that would predict how much of each color it would emit.
Right, so this is basically the Wikipedia image. Okay, and yes, it's really stupid prediction. Zoom. Yeah. Really dumb.
is its spectrum. Another fun fact, Lord Rayleigh was the guy who figured out mathematically why the sky is blue. So Rayleigh thought of this...
Well, it's really not a mathematical thing, right? Mathematically why the sky is blue? I mean, we know it's chemistry, so I guess it's not really a mathematical thing, it's chemicals, but okay, whatever.
Simplest possible object, something that absorbs all light. Objects absorb, emit, and reflect light.
Yeah, well, that's the tricky part. Absorb, emit, and reflect light. I mean, they don't really emit light unless they're, you know, burning something. Light's a force. They have to produce it. It has to be produced by something. It's just not magically delicious. Or they have to convert it out of, like magnetism's converting force into force. Converting bent space by your theory. But, yeah, gravity by rational theory into the force of magnetism. But light can't come from nothing. And it's kind of silly for people to think it could.
Rayleigh's object would only absorb and emit, but not reflect. So all you would see when you look...
Right, absorb and emit, but, you know, that requires the whole idea of a battery, you know. It goes in and then it comes back out. What's the difference? And, you know, if you reflect at a different color than you absorb, so then you're emitting a reflection. The reflection could just be at a different frequency.
At it is its glow or its radiation. Physicists call this a black body. Technically, a black body isn't black, it's glowing, but whatever, physicists. A true black body doesn't exist in real life because nothing absorbs all light and radiates perfectly. Although stars...
Well, again, if it does actually absorb the light, it does have to radiate the light unless it gets bigger and bigger and bigger. So that's sort of true. But the idea which it should have said, I think, I mean, if I was to write it, you can't find anything that's not going to reflect radiation. Some of the radiation is going to get reflected.
Stars like the sun come pretty close. Kind of funny, right? That the brightest thing we know in our solar system is the closest thing we know to a black body. Physicists. Anyway, at that time, physicists didn't really understand atoms and molecules. They thought everything was...
Yeah, well, whatever. So you're just playing with the word black body, which was used as a term to describe things that are emitting light, though. So let's just be clear. No one thought it would be black when they called it a black body.
Made of particles that vibrate like springs. Rayleigh and his...
Okay, particles that vibrate like strings, but again, this whole vibration thing and ether thing, they had lots of wacky theories back then. But I don't think they dressed like that. So that's just a gratuitous insult to the past, I'd say. They didn't have toaster ovens and expensive knife sets.
Colleague James Jeans imagined a black body made of these vibrating particles where that vibration was continuously converted to light. From that...
Okay, vibration converted into light. So again, vibrating won't just do that. You have to burn something. You have to use something up. So vibrating doesn't make light. Light has to be made of the matter, has to be converted. So three-dimensional quanta moving in all directions has to be produced into a frequency-dependent polarization that is allowed to leave the body. You don't get it for free.
That model, they came up with a rule to predict what colors a black body would radiate at certain temperatures. But the unfortunate happened. Their reasoning implied that a black body should emit infinite amounts of ultraviolet light.
Right, so right there you could say, gee, that's stupid, we got it wrong. So that wasn't even complicated, right? I mean, it's hardly a catastrophe, it's just a simple statement saying, guess what, you made a mistake, because infinite is stupid. So yeah, this was a problem just, you know, laughingly waiting for a solution, not a real problem. No real catastrophe here, just an abuse of language.
They tried to apply their usual rules of Newtonian physics and came up with not...
Yes, they came up with nothing. Usual rules of Newtonian physics. Another slight at Newtonian physics as if it's profoundly inadequate and silly, when no, it's 99.9% of the game. And if you were to just recognize that the particles of light, okay, that's what light is, and that you have to actually produce them. You can't just pretend Okay, that light just is manufactured as a byproduct of some kind of process that doesn't require energy, because light is actually energy. Yes, so we have to concede light is energy, and then you can figure out that something has to provide it, and in this case provide the polarization that makes light relevant.
Nonsense. We now call this the ultraviolet catastrophe.
Oh, Ivan Newton.
Something was very wrong with their work. A black box.
Yes, well, I mean, it was premised silly, so I guess wrong would be, yes, when you have silly premises like light isn't a thing and it's not energy, well, you're not likely to get your equations right? Yes, right.
Body can't emit infinite amounts of radiation because that would violate laws of conservation of energy, and just from like experience, when you put toast in your toaster, it doesn't promptly burn your toast to smithereens. When observation contradicts theory like this, it often means there's something missing in the theory.
I think it means it always does, frankly. Yeah, there's always either you're seeing it wrong or you're theorying it wrong. Yeah.
Rayleigh and Jeans had found a glaring error in physics theory. Bum bum bum!
Yeah, whatever that is. I'm going to so do that when I win my Nobel Prize. just so dance on your graves.
The same year that Rayleigh and Jeans published their work, a German physicist named Max Planck was studying radiation for a different reason. He wanted to understand why heat always flows from a hot object to a cold object. And in his quest to solve that problem, he unintentionally fixed their error.
Yes, he assumed the heat was stuff, and that the stuff was going from a place where there's lots of stuff to a place where there's less stuff, obviously, because stuff doesn't like stuff much. I mean, it doesn't like to be too crowded, and if there's really smashed together, and then you find out, hey, there's an extra 100 square feet over there, well, then it says, I'm going to go over there, because there's less crowdedness. Wow. Yeah, gee. Ooh. Physics.
Assumed that a black body could only emit light in discrete quantities. Its energy comes in chunks, equal to the frequency of the light.
So again, we're doing this frequency thing, so that's why I played this, just because we were sort of on that subject a little bit before, this whole, understanding this energy equals velocity or energy equals frequency thing, and it's just not, you have to think about it in the right terms, is that it's always a timed quantity. So you're using the same, you have to technically recognize that there's not more energy, that there's more potential to carry energy or to migrate energy in a given amount of time for the same amount of space, because it's more bullets. So it's just a simple analogy that if I shoot bullets 1 a second into a bucket, a mile away or something, the bucket's going to fill up at a certain rate, but if I fire the bullets every half second, then I can fill the bucket up twice as fast. It doesn't mean that the bullets have more energy, it just means that I'm firing more bullets per second. And that's where they break physics, is they think frequency has something to do with waving, and they don't realize it has something to do with quantity. So that's where the quantum comes in.
Multiplied by this, a number we now know.
Right, and what's missing from this little bit of slop here, well, the seconds are here, so okay, but it's meters per second is what you're really talking about. So Planck's constant isn't just a number, it's a number with a quantity. That's probably what this kilogram thing means. But anyway, it's a quantity per second. And that's the part that's important.
It's Planck's constant. This is weird. It would be like if your faucet could only pour full glasses of water at a time.
Well, you mean it would be like if the water only dripped from a drip with a certain amount of quantity. You need a certain amount of water to create a drip. Or it would be like the molecules of water themselves they don't come out as half a molecule, half an atom of water. It would be as if you couldn't get a half a molecule of water. I mean, it's really not that kind of difficult. And yes, this is before the word photon had been invented. So yeah, they weren't calling them photon, it was light. But I'm just saying the fact that you could kind of from Newton's time. They sort of got the idea that this light stuff is traveling in straight lines and that it lands in little tiny points. They sort of knew that part.
But when Planck assumed light was quantized, theory matched with observation.
So this is the bad line that she didn't show before, and this is the standard blah 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 blah, which doesn't really say anything, in my opinion. That's terribly interesting. Amount of radiation. This is just a vibration curve, really. This is just telling you that there's a certain, you can shake it and shake it and shake it at a certain speed, but once you get up to a certain kind of speed, the idea of you being able to stir the mixture faster, it really wouldn't matter how much faster you move the beaters. The beaters really won't do anything because you're moving the beaters faster than the cohesion of the thing you're moving it in. So the medium, let's say, of the plasma of the sun or something, you can only swirl it so fast or excite it so much, and then no matter how much you speed up the beaters, they're just not beating anymore. And that's sort of what this is saying. There's a point where it just can't beat it any faster. You can't excite the radiation. The radiation, if you want to get a higher form of radiation in a large amount, you have to create a different mechanism to cause that radiation to be produced, and you can't just do it with a mixer. That kind of thing. Heat won't do it alone.
He solved the ultraviolet catastrophe. But here's the crazy part. Max Planck...
Again, it wasn't a catastrophe. The catastrophe was they didn't know that light was energy. That's essentially the catastrophe, is they were pretending it was some kind of thing that you could have an infinite vibration or harmonic and it could just bounce around forever, and that it wasn't going to get degraded because it had to actually move stuff to exist. And so they were just kind of pretending that it would just bounce around forever, and therefore excite the creation of light, because it just bounced around forever. It's not right.
Didn't immediately realize how big of a deal this was. Nobody did. He was just doing the thing that we all do with our math homework when your answer doesn't match the answer in the back of the book, so you just switch a plus for a minus, but you're not really sure why. Planck?
I don't think that story has anything to do with it, but it doesn't really matter. I mean, there's a whole other story that, Planck did this all separate to solve a separate problem, and that the two problems merged in the future. And so a solution for a different problem was applied to this problem.
Didn't understand what his work meant in the real world. It wasn't until a couple years later that Einstein realized that
Right, so now we're changing the story a little bit. Planck didn't understand. Well, I think he did. He was pretty smart. But anyway.
These packets of energy meant that light wasn't just a wave. It's made of particles.
Oh, it wasn't just a wave. See, that's the part that's just so darling and cute. Okay, you have no evidence that it's a wave. Just none. And a wave in what? What's the medium for your wavy thing? I mean, where's the evidence that you have anything called a magnetic field when there's no magnetism? Where's your evidence that you have a gravitational field when there's no gravity? And where's your evidence that there's anything like a light field when there's no light? When the light bulb's off, do you really think there's still a light field?
That we now call photons.
Right, and we should have used the word more rationally and said that the photon gets a little bit tricky because you can't realize a photon without recognizing that it's a dual package. You have to have two of them to create a frequency. You can't have a frequency unless you have two. So I don't know exactly how you do that grammatically, but there's got to be some way to acknowledge the fact that there's actually two tons in the photon.
So then physicists started thinking about what this meant for atoms that emit those photons, and the theory of quantum mechanics began to...
Yes, no, it's the theory of quantum electrodynamics. That's what it actually was called then. Okay, it wasn't this silly quantum mechanic magic hat where you just pulled anything you want out of it anytime you want. Just make up shit like dark matter and whatever you need to fix your math. A little bit of Huygens Smoigens. Yeah, it was before all that shit. It was called quantum electrodynamics because what was understood is the connection, as Einstein demonstrated with photons, that photons can stimulate electrical phenomena. That was the first transistor. Actually wasn't a transistor, it was a photoresistor, meaning it collected light and the light created a gate for electricity.
To unfold. Atoms emit photons when their electrons lose energy, and so their electrons must lose energy in chunks, in quanta, quantum mechanics.
Well, again, no explanation of exactly that mechanism, but again, that's the problem, is quantizing it, but quantizing it inaccurately doesn't really help. So yes, they were originally wrong, then you came up with another wrong explanation to fix the wrong, and now you're still kind of wronging on it because you're still not getting it. That the energy the photon is imposing can be energy realized because of the elasticity of the field energy, the magnetism holding atoms together, and that all you're really probably doing is the trampoline thing. You're throwing something into the thing under tension, and you're getting the rebound, which is the reflected light.
The consequences of Max Planck's discovery that light comes in quanta, in packets, snowballed into what we now know as quantum mechanics.
Well, it's just such a lie, because quantum mechanics denies the particle nature of the quanta. And as she's going to say, that's why I'm making the video, she's going to start saying the you're on crack, right, stuff. She's going to start talking about the woo-woo. It doesn't know where it is. Nothing knows where it is. Everything's lost in space. That quantum mechanics has absolutely nothing to do with that original quantum electrodynamics, which was actually a rational recognition that they may have found the quanta. They might have found in the photon, they might have been realizing the smallest indivisible bit, that they actually were at the atom that was originally sought. But let's forget about all that and start doing religion instead. Purple religion.
Quantum mechanics is bizarre.
No. It's stupid. See, this is where you people get language wrong. See, bizarre doesn't equal stupid. Bizarre equals something like strange or unusual, right? See, the mechanics of the fundamental universe is not doing anything unusual or bizarre or irregular. See, that's what those words mean. It's something irregular. See, it's doing very regular things. And it's doing them over and over and over again, and it does them really reliably. Yeah, no UFOs, sorry. I mean, no magic, no leprechauns, none of that bullshit. So, bizarre is the wrong word, and stupid is the correct word for modern quantum mechanics, or retarded, or of diminished capacity, or God, you're such fools, or sucker. How did you fall for that? Dumb. And dumber.
The microscopic world just misbehaves.
No, it doesn't do any of that. It doesn't do any of this misbehaving stuff. It does very reliable things, and you're just kind of pretending, okay, okay, that you sort of kind of understand why it's doing that, but you don't, because you're just you're not getting the mechanism. You have no mechanism. You did silly things like bending space, and now you lost most of the energy in the universe you threw into bent space, and so you don't even realize that that energy is reusable inside of atoms, right? So all that bent space energy is actually what's holding all the atoms together. But you kind of lost that because you got silly and started believing silly things. The nothing is telling the something what to do. That makes sense, right? Isn't it sensible to think that nothing tells the something what to do? No, that isn't sensible. That's stupid.
We're talking many billions of times smaller than the width of a human hair. For example,
Yes, very small things. That's right.
electron can be in multiple places at the same time.
Right, prove it. No, it can't. That's just kind of silly. You're just saying so, right? Because it's fun to say so. But you have no hard evidence that anything is in multiple places at the same time. Anything has ever been in multiple places at the same time. That this phenomenon of being in multiple places at the same time has ever taken place ever in the history of the universe. You can produce absolutely nothing called hard or substantial evidence to indicate that's the truth at all. Nothing. And in the one certain little silly cases where you make up a whole theory of bullshit to explain a stupid, the simplest pattern in the universe being created, you rely on some silly thing like Huygens to create an excuse to defend your God theory. That's all it is. It's a God theory.
In fact, an electron has no precise location.
Says you, with no evidence, and it sounds stupid. You pick at it, you scratch at it, you'll find out they have nothing, no evidence of this electron in some kind of no man's land. It lands in reliable locations, and it's all predictable in a sense as long as you know what's going in. And it's just they play this game where they randomize something and then they say, well, there's a 50% probability of it doing this and a 50% probability of doing that. Well, exactly, because you obliged it to be probabilistic. But if you aim something for a change, then you'll figure out exactly where it goes. And you won't have to interfere with it.
But the weird thing is, when you measure the electron,
Okay, see, the word measure came up again. Oh, she kind of looks like a beaver. She does make a lot of incredible faces. But it's not measure. No, so when they say measure, it's not really. You don't have to be measuring. All you have to do is interact. Interact. Yes, if you interact with something, guess what? It has to be where you're interacting. And what you'll find out is that nothing ever interacts in multiple places at the same time. It can only interact in one place in one time, and that's it. So until you find something actually interacting at different times and in different locations at the same time, then your theory that something doesn't know where it is and that it's in many places at once is kind of bogus. I think, obviously.
find it in a specific place. It's like it has no location until you measure it.
Again, not measure it, you mean interact with it. So until it hits something, you claim it isn't going where it's going and where it will land. So you're just basically saying I could throw a rock really hard at the moon and you're going to try to sell people on the idea that the rock doesn't go to the moon. It decides to go to Saturn first, and it goes over here, and it goes over there, and it can go almost anywhere it wants to, and it can still make it back here in time if it really wants to, and then go to the moon. It can do almost anything, and that's just crap. It's illogical nonsense. The rock goes from here to the moon in as much of a straight line as possible, and you can basically photograph it all the way going to the moon and see that that's exactly what it does. It goes to the moon. And so if you want to go to the trouble to stop an electron at every millimeter of its travel to the moon, you'll see that every millimeter the electron is 1 millimeter ahead. It never is in some kind of location when you measure it. It always happens to be in exactly the location you'd predict it would be in, which is the location heading for the moon, because that's where you threw it. And it doesn't deviate, and it doesn't go anywhere else, and there's no evidence that it went somewhere else and you measured it somewhere else. So until you measure it somewhere else, all of this crap is crap.
This popular image of an atom is wrong.
Right, and your image is also wrong. Surprise!
Instead,
So it's dumb, and this will be the dumber version.
most of the time it looks like a cloud of probability.
It looks like, but we can have no idea what it looks like, because you can't see photons. You can't see electrons when they're spinning around atoms. And so they might not be spinning at all. That could just be an illusion of the mathematical formulae based on your standard model of weights and measures. And if you have any of those standard weights and measures in your little bag of silly quirks and whatever, queeks, all that crap doesn't go anywhere. So get one of those little bits wrong and the whole thing crumbles.
Around the proton. This cloud of probability is...
Right, the cloud of probability. Yeah, sorry, bullshit. Bullshit, 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 bullshit. Okay, the electron is a thing. It's full of quanta. It's full of stuff moving the speed of light in one-dimensional directions. And that's what it's full of. Little bits of force. And it doesn't break the law and go from here and jump over there and do any of this stupid, silly nonsense. It has to gain velocity like everything else. It has to interact with force. The force has to propel it in a direction and has to get there through these vectors. There's no magic vector. Everything has to obey these rules. It has to go this way and some this way, and then it acquires some new direction based on a combination of those vectors. And that's just the way it works, and everything works that way. And you can't just sit there and make up this nonsense that the electron is some kind of special particle that doesn't obey these rules, because damn it, it does. Damn it. Atoms are made of this stuff. They have to obey the rules, or atoms wouldn't be obeying the rules.
Is the electron. Think about it. The particles that make up your body aren't a stack of solid objects.
Says you again. And what if you're wrong? You're just saying a bunch of crap, and you call this an educational channel, and you're just misinforming and poorly educating. Because you're not describing how you have a huge collection of evidence that demonstrates any of these things to be true that you're saying. None of this has been demonstrated by conclusive, hard evidence. It's only been demonstrated by silly interpretation and basically just making up stories that conveniently fit the evidence. You have this scant little bit of evidence, the red hood and a riding crop, and now you're just making up Little Red Riding Hood and, her dark matter, evil, grandma-eating wolf.
They're a collection of probability clouds.
Oh, yes, of course. That makes perfectly good sense. A bunch of clouds collected in the nothing ultra space of happy. I mean, this is good ship lollipop physics. You're just making up crap and selling it as if you're smart people because you have made up a crappy story. And it's a crappy story. It's as synthetic and as meaningless and as useless to understanding the truth as this purple hair gimmick. It's a fucking gimmick. Bent space is a gimmick. Relativity is a gimmick. Okay? Quantum mechanics based on wave theory is a gimmick.
Quantum mechanics is unsatisfyingly unintuitive.
No, it's unsatisfyingly silly. It's fucking silly. Alright? Things don't unthing, okay, and just materialize in some other location, okay, by rules that say, well, it will only rematerialize in locations that it could have actually traveled to. And it will never materialize in locations that it couldn't have actually traveled to. Isn't that convenient? I mean, if you're going to sit there and say it can be nowhere, it can float in this floaty float, again, then you're going to have to somehow explain how the rules indicate that it can't go outside of these boundaries. Then how are the boundaries defined? If the boundaries aren't being defined by a physical property, what's defining them?
But time and again, it has proven to be real.
No, time and again, they just keep saying it's real. They just keep saying it's the most reliable theory in the history of mankind. And yes, we have to use Huygens for poor shenanigans to create a second photon in the single slit experiment to make the math work. And then even in the double slit experiment, the most famous experiment proving wave theory, they don't even calculate the pattern correctly. There's obviously two patterns produced on top of each other, superimposed on each other, and the math doesn't in any way inform anyone regarding why there's two patterns. It doesn't acknowledge the existence of the two patterns. It just pretends it's the most reliable mathematics in the universe when it doesn't really account for a goddamn thing. It's a fraud. And you're selling it for money. Makes you kind of a whore. Yeah. Whore for a pseudo-science, a religion disguised as a pseudo-science.
Applied in computer chips, lasers, even LEDs.
Oh, yes, right. What is applied is the kind of known stuff, not the magical, it doesn't really know where it is kind of crap. So it's the reliable, yes, okay, it started here, it got force that pushed it here, and basically a Feynman diagram will tell you, it's going here, and that's going there based on laws of conservation, and at no point did you have to make something not known. There's no not known needed. The not knowing stuff doesn't really help anywhere.
An electron probability cloud is only a nibble of the cookie.
Of absolute crap that doesn't really do any good. There's no probability cloud that's ever put into the mathematics, right? The mathematics uses the reliable part of the probability, which is we know it's going to be here at least this % of the time. And so they're depending on the fact that it's pretty dependable. So I don't know what this whole excuse is, the eat a cookie thing. Physics teaching.
Is quantum weirdness. And after more than 100 years of study on the topic, there's still more to learn, which is...
Yes, well, there's still more to learn, like you have gotten everything wrong for 100 frickin' years. Not one of you little Einsteins, could spend 10% of what it costs for this one stupid pipe. So if you just took the money you wasted on this one stupid pipe, okay, and spent that on doing the two-slit experiment in a really thoughtful scientific manner, where you really tried to aim the electrons at the surfaces, or tried to aim photons even at the surfaces, and see what would happen. Because that way you don't have to measure them. If you aim them, you don't have to measure them, because then now you know where they're going. So you already measured one of the components, and now you won't destroy the other component, okay, when you measure it. But anyway, it doesn't matter. The point is if you aim them and you do the experiment, you're going to find out that, hey, you know what? It changes where it lands based on how close it is to the surface. Yeah, who figured that? Yeah, well, maybe Newton did. Yeah. So all this crap is built on an edifice of mumbo-jumbo, seeking God and the Holy Ghost. It's just bullshit. Fail, 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 fail.
Why we're doing things like colliding particles at the Large Hadron.
And misrepresenting the truth regarding single-slit diffraction and how it produces exactly an interference pattern, an on-off pattern, the simplest pattern in the universe. Okay, and then how you faked the truth by saying, let's Huygens on the single slit. We won't Huygens this. We'll use a principle, and we won't apply it anywhere else in the universe except where our math is broken. Now, if that isn't a contrivance, if that isn't shenanigans, if that isn't cheating the truth, and that's really all you people are doing. You're just living a lie, selling a lie, and that's not nice.
Collider, just as a small example. I love this story because it shows how...
Yes, they're all fucking stories. They really don't have a damn thing to do with the truth, do they? It's just stories. You're just telling stories, like a little soap opera. Yeah, the purple hair story.
Important it is to be wrong.
Right, that really makes sense. It's really important to be wrong, so then you could be wrong again, and then you could be wrong again. And you can keep replacing the wrong answer with the wronger answer. And then you can see how catastrophically wrong your answers are going to be. So again, why doesn't physics just, grow up and be completely wrong and just say the angels are doing it, or the leprechauns? That it's God's notion that will decide where the photons go.
Science isn't...
Because it doesn't have a damn thing to do with fucking physics. Physical phenomena. Now, this doesn't have anything to do with physics.
facts and figures. It's constantly being modified and improved.
No, it's constantly having new additions, new made-up adventures for Goldilocks, you know, and Red Riding Hood. And that's all you're doing. You're just adding new stories, new adventures. So you did the Wednesday adventure, and now you're just going to make up a story for Thursday and a story for Friday. But they're all fucking stories made up of nothing. Nothing called evidence or science or any of that shit, or logic or reasoning.
Without really uncovering this huge theoretical error that was...
No. You're saying that Planck wouldn't have figured out that, you know, photons are quanta. Of course, that would have been discovered. So you didn't need somebody to make a mistake to figure out that, because I don't think Planck was deliberately working on it. You even admit that in your story. Your story even admits that Planck may not have even given a shit about this whole Rayleigh thing when he did his work, and there's no real evidence that it was obsessing Einstein either. So, this is just crap you're saying here.
Ultraviolet catastrophe, physicists may have never come up with the rules to describe a brand new, tiny universe.
Yes, whatever. A brand new, tiny universe that's so big that's as big as the big universe. The tiny universe just happens to make up the entire big universe. What a surprise. And you silly people are the ones who have separated that. You've taken the universe out of the universe because you're pretending that gravity's affecting big things, when no, gravity's affecting the little things. Like every other force, it's all little thing forces. There is no big universe. The big universe is a fake, okay? The big universe is made out of the little universe. It's like if you could see that the life on Earth is, you know, all the complex organisms are made out of living things. So if you saw the living things and you didn't see the schools they clumped into, so if you just saw the fish and not the schools of fish, you'd see a different universe. And you maybe could understand some of this stuff. But you're looking at the trees, and you're not seeing the phloem and the xylem. You're not seeing the cells that make it up.
Thank you so much for watching, and happy physicsing.
Yes, really. This happy Jesus, you know, Jesus loves you. Why don't you just start saying Jesus loves you? Oh, this is just such gross physics. It's gross. So, yes, played by. So, Lord Raleigh played by Kyle Kitzmere. And I'm sure he really appreciates this sloppy representation of his endeavor to add to the knowledge of mankind. I'm sure he loves being mocked for it. Yes, thank you very much. I can just hear him saying, thank you for ridiculing me and making me look like an asshole for trying to answer questions and doing real science, not just dyeing my hair purple. No, I actually did real fucking science. But yeah, thanks for the ridicule. Really appreciate it. I don't think that's what he's saying. I don't think you're actually making his father feel really good either. Like, oh man, my son was such a fucking loser. They're mocking him all through time now. Our whole family has been disgraced. I mean, just lay off the dead, huh? Or, you know, make a fair argument. This isn't fair argument. He couldn't even tie his tie. That's not a fair argument, you shithead. Yeah, fuck you, cunt. So this is now, like I say, physics girl is really physics people. You know, a whole bunch of people have to do it. Sophia and Jibberabble and who else is in here? Ashley and Kyle. Yes. But anyway, yuck. I don't know what this is. Fortunately, I don't know what that is. Good. But animations are important. We have to do all the little cartoons to keep all the people involved and interested. Oh, little XXOs. So it equals happy smiley. Happy smiley, happy smiley, funny, funny, happy, happy. Yeah, PBS, fuck you. You have what's the word for you've lost the menu, the program, the memo sheet. I don't know. You lost the email. I don't know. There's something, but you've lost it. Yeah. So anyway, that was just horrible. But that's physics now, right? So it's all this show physics. Unchallengeable. We're an elite of buddies. You know, me and Bill Nye have lunch together and conspire to keep the human race stupid and believing in absolute nonsense, because none of us has spent any time whatsoever actually researching any of this shit to see if any of this crap makes any sense. I mean, really. I mean, the whole Einstein lensing thing, for fuck's sake. Hubble telescope. Why isn't it lensing the sun every frickin' day, showing me all kinds of weird optical effects created by the lens that is the sun? Oh, that's right, because they're not happening. And nobody will admit it. They just won't admit that, oh, that's a problem. Yeah, that's a problem. Yep. They don't want problems, because then they have to invent fake things to fix them, instead of admit they have it wrong. Okay, enough. So, till the next, whatever, the next argument against silly religious physics and such. Heisenberg, uncertainty, mishmash, dead cat in a box physics with purple hair. Purple cats. I guess they should make it purple. So anyway. So should I add anything? Yeah, well, see, the radiation thing is important. See, just understand that to create one of these high-frequency photons does require very quick movement by an electron. It has to start and stop really abruptly. Okay, so there aren't a lot of things in the universe creating X-rays, you know, and high energy, high frequency radiation. And it's only when you get to like background radiation, cosmic rays and such. But there isn't a lot of that stuff, because it isn't produced regularly by common atomic function. Atoms just don't have the capacity to move that fast, the bits inside, to actually create frequencies that short. Yeah, it's kind of like they just can't, there's a trigger speed, and they can't pull the trigger any faster than a certain speed because of the mechanical limitations of the mechanics of the atom. The atom won't let them pull the trigger any faster. That kind of thing. Okay, anyway, that's the real science. Okay, till next time.